Hello guys, in this video we're doing addition reactions. Addition reactions takes place in unsaturated compounds. They are generally faster than substitution reactions. They take place according to Markovnikov's rule. Markovnikov's rule states that in addition reaction, hydrogen attaches to a carbon with a greater number of hydrogen atoms. A major product will be formed. The types of addition reactions: halogenation reactions, which is the addition of a halogen to an unsaturated compound to form a haloalkane. For the reaction to occur, we need ultraviolet light or sunlight to break the Br-Br bond or a halogen bond. It might be Br-Br or Cl-Cl or FF or iodine-iodine bond. It might be FF or chlorine to chlorine bond or Br to Br bond or iodine to iodine bond. Let's have an example. In this case, we need ultraviolet light, UV. Then what happens here when these two react? This double bond will break and open these positions. Our product will look like this. The positions that opened during the breaking of the double bond. Then these two, they are going to be attached. So both of the chlorine atoms are going to be added. That's why it was called addition reaction, because we are just adding. There's nothing that we take out. Addition reactions, they have only one product. We don't have two or more products, just one. So the reason why we say addition reactions are faster than substitution reaction, because we only need energy to add these two chlorine atoms. Unlike in substitution, you need to take out something, then you put in something. So you need energy for taking out and put some. In this case, we just put. So we need less energy. That's why addition reactions are faster than substitution reaction. It's prop. This is on carbon number 1. This is prop 1 in plus chlorine, which is ClCl. Let me just leave it like that. Then we form this one. We have 1, 2, 3 carbons. So it's these chlorine atoms that are attached there. So what we do here, we count the number of carbons. So this is carbon number 1, carbon number 2, this is carbon number 3. So it is on carbon number 1 and 2. So we say 1, 2, there are 2, so we say dichloro propane. Hydrogenation. This is the addition of a hydrogen to an alkene or any unsaturated hydrocarbon to form an alkane. The reaction requires a catalyst. So in this case, we use nickel, platinum, or palladium catalyst. Let's have an example of ethene reacting with hydrogen to form ethane. During the process, this double bond is going to break, then it opens here like this. The hydrogen is going to be added across the double bond. Now we have ethane. The ethene plus H2, then we formed ethane. Platinum is a catalyst. Hydration. This is the addition of water to an unsaturated compound to form an alcohol. Concentrated sulfuric acid is used as a catalyst in this reaction. For example, in this case, we follow Markovnikov's rule. So the first thing I can do here, let us break this double bond and open this position and see the possible products that we have. 1, 2, 3. So these are the two positions that are open to add our hydrogen ion and the hydroxide ion. So we want to know which one is the major product and the minor product. So since we said we might form two possible products, so let me add also this side. In this case, to determine where to substitute our H plus or our OH, we follow Markovnikov's rule. Markovnikov's rule states that the H plus ion is attached to a carbon with more hydrogens. So in this case, we have these two carbons. This carbon you have 2, which is 1, 2. Then this one you have 1 hydrogen. So meaning the H plus is likely to be substituted at this carbon that you have more hydrogen on its backbone. So H is going to be substituted there, then OH will be substituted here. Then we say a major product is formed. On this side is the reverse. the H plus will be substituted to a carbon with fewer hydrogen, like this. So this is the minor product, meaning it's not likely to be formed. The reaction requires sulfuric acid, so you add your H2SO4 concentrated here. Hydrohalogenation. This is the addition of a hydrogen halide to an unsaturated compound to form a haloalkane. The hydrogen halides that we mean is either it's HX. Hydrogen halides is either HF, HCl, HBr, or HI. Let's have an example. In this case, we can also form a major product and a minor product. So these are the positions that have opened for the addition of hydrogen and bromide ion. So in HBr, we have H plus ions and Br minus ion. But according to Markovnikov's rule, the H plus is going to be attached on the carbon with greater number of hydrogen. So in this case, this is the carbon that have greater number of hydrogen. You can see this one is 2, then this one have 1. So our H plus is going to be attached there, then it becomes H like that. Then the Br will be attached here. So this is our major product. The minor product is the opposite. H plus will be attached here, then our Br there, then the minor product.